In this lesson, you will be learning the concept of ensemble learning. By the end of this lesson, you will be able to explain ensemble learning, evaluate the performance of boosting models. Overview. Ensemble technique combines individual models together to improve the stability and predictive power of the model. This approach permits higher predictive performance compared to a single model. Ensemble finds ways to combine multiple machine learning models into one predictive model in order to decrease variance using bagging, decrease bias using boosting, or improve predictions using stacking. Let's understand the ideology behind ensemble learning. As you have seen before, certain models do well in modeling one aspect of the data, while others do well in modeling another. Instead of learning a single complex model, learn several simple models and combine their output to produce the final decision. In ensemble learning, the combined strength of the models offsets individual model variances and biases. Ensemble learning will provide a composite prediction where the final accuracy is better than the accuracy of individual models. Ensemble methods can be divided into two groups: sequential ensemble methods and parallel ensemble methods. In sequential ensemble methods, base learners are generated consecutively, that is, at a boost. The basic motivation of sequential methods is to use the dependence between the base learners. By weighing previously mislabeled examples with higher weight, the overall performance of a model can be boosted. Parallel ensemble methods are applied wherever the base learners are generated in parallel, for example, random forest. Since the errors are often reduced dramatically by averaging, the basic motivation of parallel methods is to use independence between the base learners. Here in the given diagram, we are using parallel ensemble method where the different models work best in one or other aspect of data. They are combined in the ensemble model where the best aspect of each of the models is considered upon the input data, and then ensemble learning model comes up with the predictions. Ensemble model is the application of multiple models in order to obtain better performances from a single model. Performance depends on two major factors: robustness and accuracy. Ensemble models incorporate the predictions from all the base learners. This provides robustness. Ensemble models deliver accurate predictions and have improved performances. Ensemble Learning Methods Part A. You can create an ensemble by combining all weak learners. Once weak models are properly combined, we can obtain more accurate and/or robust models. You can also create an ensemble of well-chosen, strong, and diverse models. By combining data from numerous modeling approaches, ensemble models gain more accuracy and robustness than a fine-tuned single model can gain. Model averaging is an approach to ensemble learning where each ensemble member contributes an equal amount to the final prediction. In the case of regression, the ensemble prediction is calculated as the average of the member predictions. In the case of predicting a class label, the prediction is calculated as the mode of the member predictions. In the case of predicting class probability, the prediction can be calculated as the argmax of the summed probabilities for each class label. A limitation of this approach is that each model has an equal contribution to the final prediction made by the ensemble. There is a requirement that all ensemble members have skills compared to random chance, although some models are known to perform much better or much worse than other models. A weighted average ensemble is an extension of a model averaging ensemble where the contribution of each member to the final prediction is weighted by the performance of the model. The model weights are small positive values, and the sum of all weights equals 1, allowing the weights to indicate the percentage of trust or expected performance from each model. Now let's take a look at what bagging is. The idea behind bagging is to combine the results of multiple models to get a generalized result from a single model. Bagging or bootstrap aggregation reduces variance of an estimate by taking the mean of multiple estimates. There are 3 steps to perform bagging. Step 1 is to create randomly sampled data sets of the original training data, bootstrapping. Step 2 is to build and fit several classifiers to each of these diverse copies. Step 3 is to take the average of the predictions to make a final overall prediction. Ensemble Learning Methods Part B. Let's understand how random forest is an ensemble learning model. Random forest is a good example of ensemble machine learning method. Random forests, as one can guess, combine various decision trees to produce a more generalized model by reducing the notorious overfitting tendency of decision trees. Random forests are utilized to produce decorrelated decision trees. It creates random subsets of the features. Smaller trees are built using these subsets, creating tree diversity. To overcome overfitting, diverse sets of decision trees are required. Boosting is a sequential process where the errors of the previous model is corrected by each subsequent model. Let's assume an example of different types of body pain and their diagnosis. Headache, stomach pain, and leg pain will have a different reason. Let's assume that X causes headache, then X will not cause leg pain because Y causes leg pain. These 2 variables are not the reason for stomach pain. Stomach pain will be caused by variable Z. Depending on the results of weighted opinions, the doctor will suggest the diagnosis sequentially. Let's understand the way boosting works in the steps flow. Step 1 is to train a classifier H1 that best classifies the data with respect to accuracy. Step 2 is to identify regions where H1 produces errors and weighs to them and produces a H2 classifier. Step 3 is to aggregate those samples for which H1 gives a different result from H2 and produces H3 classifier. Repeat Step 2 for a new classifier. Let's understand what AdaBoost is and how it works. Let's first understand boosting. Boosting is a technique of changing weak learners into strong learners. In boosting, each new tree is a fit on a modified version of the original dataset. AdaBoost is one of the first boosting algorithms to be adapted in solving practices. AdaBoost helps you mix multiple weak classifiers into one strong classifier. Let's understand this through a scenario. Consider a scenario where there are plus and minus symbols indicating the data points. We will try to understand AdaBoost workflow. Working of AdaBoost. So the first step is to assign equal weights to each data point and apply a decision stump to classify them as a plus or minus. The most suited and most common algorithm used with AdaBoost is a decision tree with one level. These trees are short and solely contain one decision for classification. They are often called decision stumps. As you can see in the given graph, decision stump D1 has generated a vertical plane at the left side to classify the plus. A decision stump is a decision tree. It uses only a single attribute for splitting. For distinct attributes, this typically means that the tree consists only of a single interior node. Now apply higher weights to the incorrectly predicted 3 plus as shown in the given graph and add another decision stump. You can see that the size of 3 incorrectly predicted plus is bigger than the rest of the data points. In the second step, the second decision stump, D2, will try to predict them correctly. So as you can see, D2 has classified 3 misclassified plus correctly. D2 has also caused misclassification error to 3 minus. In the next step, D3 adds higher weights to 3 minus.